In this module, we'll try to think like a coder as we start working on developing logic, which is critically important when learning to write programs. We'll begin by looking at the software development lifecycle before investigating algorithms as a useful first step in designing logic before you write code. So far, you've discovered quite a lot of things about computer programming. Over the last module, you learned about various programming constructs such as loops, conditionals, handling input and output, functions, and even conceptual insight into object-oriented programming. These are the weapons at your disposal, but how do we use them to write programs? This is where you need to step back a bit and think about how you would approach a problem and create a solution. This is where the software development lifecycle comes into play. The first step in this process is planning, which entails creating goals, defining scope and purpose of the application. This is sometimes known as the feasibility step as well, since you also analyze the feasibility of the project. This is followed by the analysis stage, where the requirements of the project are defined and alternatives evaluated. This research is critical to understanding the specific needs of the consumers. Also put to plan are thoughts for building the prototype edition of the application and the creation of the software requirement specification document, which lists everything from software to infrastructural requirements of the project. Then comes the design phase, where you define the architecture, the inner workings, and the entire approach to solving problems as understood in the previous phases. This is very critical because it sets the ground for the actual code and solution to follow, and is also the stage where you decide on the algorithms and programming models in addition to designing user interfaces and other elements. What follows is the development phase, where actual code based on the outcomes of the design phase is written and the application is built using programming languages, technologies, and platforms that were agreed upon earlier. The next phase is testing, which entails thoroughly testing the application to ensure it delivers on the requirements laid down earlier and behaves as expected. This is done using a variety of methods, often involving automated testing mechanisms to ensure the software is free from bugs and performs as per the expectations laid down earlier. Next, this thoroughly tested application is deployed in the deployment or implementation phase, which basically means that it is now available to users to consume. For websites and applications, this would mean deployment on the cloud and making it available for consumers to use. For mobile apps, this would be publishing to the various app stores for people to download and use. The last stage in a software development lifecycle is maintenance, where the team continually monitors the application for any undiscovered bugs and works on a plan to iteratively improve the software based on user feedback and analysis. Out of these 7 stages of the software development lifecycle, let's focus our attention on 2 stages, design and development. While development is clearly the stage where actual code is written, it is the design stage which sets the gears in motion for the developers to write code. One of the key things that will happen in the design stage is approaching the solution from the lens of an algorithm. An algorithm is a sequence of steps needed to achieve a task. Now, this might sound precariously close to a recipe or even a program, and you're right. An algorithm is like a recipe and is like a program. However, the distinction is in how you express your steps. Algorithms will use simple grammar and plain English language sentences to describe the steps and logic needed to achieve a task. This can then be refined into pseudocode, which is an intermediate level step that aims to be closer to programming logic. And finally, pseudocode can be turned into real programs using high-level languages. While this process is not set in stone, it provides a clear pathway for turning ideas and logic into real programs that deliver on expectations. Algorithms allow you to solve all kinds of computational problems and can go from very basic to complicated algorithms that solve critical requirements on the basis of complex analysis and knowledge. At this point in time, we'll define our algorithms using simple and easy to understand grammar. However, algorithms can be expressed in many ways as you learn along your learning journey. In fact, we humans do things sequentially, much like an algorithm, And if we express daily tasks as simple abstractions, we do end up with an elementary algorithm. For instance, let's consider the case of making instant coffee and turn it into a simple algorithm. You'll begin by pouring water into a saucepan. Then you'll pour instant coffee powder in a cup. You'll then place the saucepan on the stove. You'll then switch on the stove. Then you'll wait for the water to boil. If the water has reached the right temperature, then we would turn off the heat, pour water into the cup, add sugar if you feel like it, stir and enjoy the coffee. If the water has not boiled as yet, we'll check if the stove is on or not. If not, then switch it on and go back to step 5, which is where we are checking if the water has boiled or not. Now, I must mention that this is one way of making coffee and you might have your own version of the algorithm with custom steps. But as you can observe, this process makes it easy for us to envision all the steps necessary to achieve our objective, and if you look closely, you can also spot familiar elements such as conditional steps. This breaking down of a task into elementary steps is a critical skill for a software developer. So over the next few videos, let's go from algorithms in our daily life to solving elementary computational tasks using algorithms. The rule of thumb here is the ability to break down a task into elementary steps. And while we are at it, we'll also convert computational tasks to pseudocode.